And the reason why we know it's linear is that it's the same gap between every one. Everybody agree with that? Now, this is a gap of minus 0.2. Whatever the gap is, always comes in front of the x. So we already know it's a minus 0.2x plus b. The next thing we need to do is we need to test one of the terms. So we know that f1 equals minus 1. Everybody see that? f1 equals minus 1. Or is it f0? It's actually f0 because of x equals 0. So we actually have f0 equals minus 1. So plug in 0. So minus 0.2 times 0 plus b equals minus 1. This implies b itself is equal to minus 1. And then what should happen next is this. It should be that fx for this question is going to be minus 0.2x minus 1. All right, you guys? Yeah. Yeah, I might just go back and hit one of them now. All right. So F1. Sorry guys, one other thing. It's getting bigger by 0.2, not getting smaller by 0.2. Would you agree with that? So it's actually a plus 0.2 in this case. It's 0.2x take away 1. Now the reason why I spotted that error was I was verifying my answer in my head. So if you go to your calculator and you put in 0.2x take away 1 and you start at 0 and let's say for argument's sake end at 5 and just do a step of 1, you should find that all these numbers I'm about to go through have to match your list. Minus 1, minus 0.8, minus 0.6. So you should verify your answer before you move on. Okay. Just while we're here, I'm going to do part 4. Okay, just to hit the point home that we're starting off at 0. Okay. So fx equals ax plus b. In the case of part 4, are we going down in 5 or up in 5? We're going down in 5. So this one is most definitely a minus 5. So what do we do with the a value? Minus 5x. There we go with that. Plus b. How do we know it starts at f0 again? It's written in the language, isn't it? Starts at 0. So f0 will equal what, guys? f0 equals minus 2. So it's minus 5 times 0 plus b equals minus 2. This implies b equals minus 2. Yes? X greater than or equal to 0. If it said x greater than or equal to 1, you'd start off at 1 and go above, okay? Sometimes the fine print is a bit weird because in sequences and series, you only ever start off at 1. You start with T1, T2, but you guys haven't done that yet. So you can easily get mixed up, so make sure you read specifically what it says. So what is the formula for this one, Connell? Minus 5x. Yeah, you can check your answers there. 0 will give you minus 2, 1 will give you minus 7, 2 will give you minus 12. We're good to go. Is that all right? All right, let's do question 6 now. All right. All right. First of all, are these ones are linear more than likely? So what's the first one? 3. How many in the next one? 6. And then finally 9. 3, 6, 9. All right. So 3 is to 6 is to 9. I would say you have to start off at 1 here. Can anybody tell me why you have to start off at 1? You have the first pattern, the second pattern, and the third pattern. You can't have the 0 pattern, can you? No. All right, guys, so here's what we're going to do. So we're going to use that formula from earlier, aren't we? What was it? It was ax plus b, all right? And what can we say the a value is? Which is 3. And what can we say f1 is? f1 is 3 times 1 plus b, and what's the answer? 3. This implies b implies fx equals 3x. Everybody cool?
Why do you start on F1 and that?
Because it says this is the first pattern, that's the second pattern, that's the third pattern. Zero pattern wouldn't exist in this case. That's what I mean. The questions are a bit misleading. You usually always start at 1. But in question 3, you're asked to start at 0, which is unusual, but it is what it is, okay? All right, how many matchsticks in this one then? 4 after that, 8 after that, 12. Anybody know the answer already? It's going to be 4x, isn't it? Why is it going to be 4x? If I wrote this out, that'll be 4x plus b. And then it's going to be 4 times 1 plus b. And how many are in the first one? 4. And once again, you can see that b will end up being 0, and we'll end up turning that into 4x. Is that okay with you guys? I think the next one works out slightly differently though. 3, 5, and 7. This one's going to be slightly different. All right. So once again, if I go back through my system, okay, what's the a value this time? Huh? The a value this time is 2 because it goes up in 2, so a is 2. And what's f1, so to speak? f1 equals 3. 2 plus b equals 3. So what does b equal in this case? B equals 1. So the answer this time will be 2x plus 1. Is that all right? You all good? Okay. Question 7. I know you didn't have to do it. Is it linear again, is it? All right. Let's highlight keywords here. 2 different billing plans. Plan A, where it's €35 per month with a down payment of 70 quid. Plan B with repayments of €24 per month. So I'll highlight plan B in a different color. With down payment of 125. If X represents the number of months of the plan, write an expression for each billing plan. Write the number of a number sequence representing the cost for each month. For the first 4 months, after how many months would both plans have repaid the same amount? Okay. So, alrighty. So here's what I suggest we do. What's plan A after 1 month? How much have you spent after 1 month? 105. Okay. So 1 month, 2 months, 3 months, and 4 months. Okay. So for this one, for plan A, it's going to be what do we say? It's going to be 105. Then after that, add on another 35. After that, 210. What about plan B? How much would you spend in the first month? All right, after that, add on 24s. Add on 24. 173. After that, 197. And after that, 221. After how many months would both plans have repaid the same amount? Have repaid. One sec, lads. So first thing I'm going to do is I'm going to establish two formulas for both plants. I'm going to start off with the red plant, and we're going to do the same trick we did in the last question. What was the last question we did? AX plus B. What's the A value? The gap in between them is 35. 35x. What about the billing amount? The initial amount was 105. You don't need to do that again because you know you're going to add on 105, don't you? Try it out. What happens when x equals 1? What do you get? Oh, wait. No, I'm wrong actually, guys. I'll explain why I'm wrong. The system I'd be using there would start from x equals 0, not x equals 1. So we will do our system after all. So here's what we're going to do. Okay, ready? So fx equals 35x plus b, and that equals 105. f1 equals what, guys? Sorry, f1 equals 105. So f1 equals 35 plus b equals 105. Therefore, b must equal. Are we happy with b equals 70? Okay. Now that we know that b equals 70, what we can say here is that it's 35x plus 70. Quickly test it out. When x equals 1, it's 105. When x equals 2, it's 140. And when x equals 3, it's 175. So we're sorted, all right? Now do the blue one. How do you do the blue one? AX plus B. So once again, what's the gap this time? 24x. Now, what's F1 in this case? F1 is 24 plus B equals 149. Then B will equal, what will B equal? 100 and what? 135? 125. Is that all right with you guys? So what's the formula for fx then? 24x plus 100 and test it. What happens if you put in x equals 2? It'd be 48 plus 125, which will give you 173. We're sorted. We want to find out after how many months both plans will be equal to each other. So when does the red plan equal the blue plan? How do you write that? When does 35x plus 70 equal 24x plus 125? Move them to one side and we get, what's that? 11x equals 55. And then after that, x equals 5. X equals 1 was the end of 1 month. X equals 2 is the end of 2 months. Therefore, x equals 5 will be the end of 5 months. Everybody get what you're saying? And the end of 5 months, think about it. Imagine you start, it's like 0 to 1 month is x equals 1. At the end of the first month is x equals 1. At the end of the second month is x equals 2, and then that carries all the way down, doesn't it? So 2 to 3 is x equals 3. 3 to 4 is x equals 4. And finally, at the end of the 5th month is x equals 5. Everybody cool with that? All right. Question 8. Is 8 a quadratic sequence? Huh? Both. Awesome. All right. Question 8. A biologist counted the number of bacteria grown in culture every hour. 4, 7, 14, 25, and 40. All right, Colonel, what's the gap? Yeah, and then what's the difference of the differences? This implies that this is a quadratic equation. Everybody cool with that? What's your Tn formula for a quadratic equation? Oh, sorry, what's your... Yeah, it's this, isn't it? I gave you this the other day. An squared plus c. Okay, everybody cool with that? Now, does it say x? Does it give us a... It says t. We'll just change them to t's at the end. Is that okay? So every hour. So T1 would be the first hour at the end of the first hour. T2 is at the end of the second hour. T3 is at the end of the third hour. T4 is at the end of the fourth hour. So, right. Basically, T equals 1 would be a result of, if T equals 1, F1 equals 4. Everybody cool with that? If T equals 2, which means at the end of 2 hours, F2 would be what, guys? 7. Yes? Oh, sorry. He started with 4. So T0 is 4. Yeah, that's perfect. Sorry, my bad. Because the bacteria can't appear out of nowhere, and you have to start off with a certain amount of bacteria to grow the bacteria. In this specific case, you would use T equals 0 and not T equals 1. I think the hardest part of the questions is choosing whether you're starting off at 0 or 1. Seems to be the hardest part. So once again, we go back. The bacteria don't appear out of thin air. You need bacteria to start the experiment off. So it's actually F0 equals 4. And then it's going to be F1 equals 2. Good man. Yes. Just sign the journal and you know what to do. F1 equals 7. Everybody okay with that? Okay. Now, what's the A value? So what I'm going to do in this question is I'm going to change the equation to this. See my Tn equation? I'm going to change it to this. Ft equals AT squared plus BT plus C. Everybody cool with that? Because we're not using n. N will start off with n equals 1. So I have to re-specify this to start off at t equals 0. Okay. Now what's the A value? Half the second difference, so the A value is going to be 2. Everybody cool with that? So it's going to be 2t squared plus bt plus c. All right. Now we're going to have to start off with what you told me. Start off with F0. Is that okay? So what do we do for F0, guys? 2 times 0 squared plus b times 0 plus c equals 4. This implies c equals 4. After we do F0, what's the next step? We do F1, where you replace t with 1. So F1 would be 2 times 1 squared plus b times 1 plus c equals 7. B plus c, that's a 2 on the left, bring it to the right and it becomes a minus 2. So b plus c equals 5. We already know that c equals 4. So this implies b equals 1. We all good? Now, I should test my equation to make sure it works. So I'm going to write down the full equation here. It's going to be 2t squared plus 1t plus 4. I'm going to take out my calculator. I'm going to put in the table function using x's, okay, because that's the only thing I have to work with. And I'm going to start at 0, correct? And if it doesn't work out, then I know something's gone wrong. Start at 0, I know, end at 5, step at 1. Are those the numbers I want? 0, 4, 1, 7, 2, 14, and finally 3, 25. Are they the numbers we started off with? Yes, they are. I'm in business. It means I got it right. Okay? I'll pause there. So what we did was we got a formula for the number of, I should have read that, 4 being the initial number present. So hence specifying T0 is 4. Show that the sequence contains both a linear and quadratic element. Okay, what's the quadratic element? We just got it, didn't we? The number of bacteria is the quadratic element. However, the linear element is what, guys? The linear element is the time. Because time goes 0, 1, 2, 3, and 4. Time is linear. The amount of bacteria is quadratic. Using f of t and trial and error, find in which hour the colony will reach 529. There's a lazy way of doing this. There's two ways. There's trial and error, but we don't have to use trial and error because we have the super calculator. So I'll show you what I mean in a second. Get out your calculator. Put in the formula, the red formula, okay? The formula, where did it go? You go start at 0, end at 20. Step of 1. Keep going through the list until you find the number you're looking for. What did you say it was? What did you want? 500 and? 529 happens somewhere between 15 and 16. Would you agree with that? 20, because you didn't know it was 15. So would everybody agree it happens somewhere between the 15th and 16th hour? Does that make sense? Now, how would you show that in an exam? Here's how you cheat your way to showing this. What I would say is I just go, oh look, I tried F15. I say 2 times 15 squared plus 1 times 15 plus 4. And then I say, oh, that gave me an answer of 469. Then I'd go, okay, next thing I did was I tried F16. And then the examiner will well know that you only took, the fact that you only took 2 attempts means you definitely used the calculator, but that doesn't matter because you showed your workings. And then 529, we've surpassed that, haven't we? And we've got 532. Okay. The second method for doing this is the minus b formula, where ft equals 532. So you're going to get 2t squared plus 1t plus 4 equals 532. Bring it over to the other side. We already know it doesn't go unevenly. So it's 2t squared plus 1t minus 528 equals 0. Somebody do the minus b formula for me. You should get a is 2, b is 1, minus b is minus 1. Colin, will you do the minus b formula for me in the calculator? I'll write down what you have to do. Okay, it's going to be minus 1 plus or minus. Why do I not need to be concerned with the minus answer? Why do I not need to be concerned with the minus answer? Has to be a positive number for time. Okay? Shh. So only put in the positive number at the start. So I don't even bother with the minus. And what we do next is we do b squared, which is 1 squared, plus 4ac, which is 2, by minus 528. You already know the answer has to be between 15 and 16. If it isn't, there's an issue. Yes? Just sign the journal. Apparently the... Alright, just give me a sec, lads. There's no such chance the calculator made an error, which would be highly unusual, but look, we'll give it a go. So what I'm going to do is I'm going to put 2 times 16 squared plus 16. I'm just going to do it manually. Usually the calculator is infallible, but here we go. Let's try it out. That is not 0. It appears my calculator is broken. Awesome. Great time for that to happen. So in that case, the answer is t equals 16. Lads, did anybody, when you put it into your own calculator, did you guys get 529 on your list? Interesting. I'm going to try plan B here. I'm going to use the second calculator, and we're going to see if something just went wrong with my software more than anything. It is 2t squared plus 1t plus 4, isn't it? Okay. We start at 0. We end at 20, and we go up in ones. And when I go through my list, I'm looking for 529. It shouldn't exist. It doesn't. It goes straight to 532. In which case, somebody might have messed up with the minus b formula, so we'll try this again. Minus 1 plus square root 1 squared. This is not explainable. 2 times minus 528 all over 2 times 2. And 16 on the money. No, it's all right. It's gonna. It's not 532. It's 529. Read the question again. It's 529. 532 is what I got in my. 532 is what I got in my answer. So change the C value. What's the new C value? The new C value is 525. Change that to a 5, and therefore it cannot be 16 on the money. It's impossible. 15.95, which is essentially the 16th hour. What happens in between the 15th and 16th hour? Yes. Is that okay?